So thank you very much for your kind invitation and give me an opportunity to present my faculty. And thank you for having generous half an hour. I don't need so much time. 15 is enough, so if you have some questions after my presentations, you are welcome for that, and we can discuss later during, for example, coffee break, if you are interested. So, our faculty, the Faculty of Physics, Astronomy and Applied Computer Science, and so very short story of the long history. As you know, our university was founded more or less in the middle of the 14th century, but the first Collegium Physicum, so let's say so one can define as a physics department, was established in 1791, and this first building were in the actually middle of the very close to the center of the city. And after some time, well, with some, of course, turbulent history of Poland, we were moved to Collegium Physicum, that is still in the center of the city. This is the old building, and the physics department was located with its experimental facilities in the basement of this building. And 50 years later, more or less, we were moved to our previous location. This was like 1967, and again 50 years later, we have moved just to the new place. Actually, this is our new place. It's already 5 years, so maybe it's better to use the past time here. So we moved to this new buildings, which is on the opposite side. We face the chemical department. So if you wish to visit our place, I can show you some places which is interesting in our new location. Short discussion of our department. We have 23 departments in physics and biophysics, 4 departments of astronomy, 3 departments of computer science, and altogether more or less 42 laboratories of different kinds. We have like 66 senior scientists, professors, about 120 doctors, assistants. So students, so as you see, mainly these are students of computer science, about 500. The students, physics and biophysics, this is 210. And we have some courses in advanced material and nanotechnology. This course we shared with chemical department with about 100 students, and astronomy is about 80 students. So these are bachelor and master curricula, and for a PhD student we have more or less like, as you see, 150 students. Among them about 10% are international from different countries. This is some numbers. So in summary, we have bachelor and master studies in physics, biophysics, astronomy, applied computer science, and then PhD studies in those 3. We still do not have PhD studies in applied and computer science, but now, as you know, we move to the new legislation. We are after the legislation process. We have a new law in Poland, and we probably in future, in the very near future, we also open applied and computer science PhD studies in our plans. And what about research? So let me define this research in few parts, and let me start with material science. So in material science, we have researchers who work, and here are some lists of interesting subjects. So these are electronics, some new concepts in electronics of different kind. We are working molecular electronics, atomic scales, logic structures and interconnects, graphene nanoribbons and nanoprobes, nanotechnology, surface science. We have quite a lot of laboratory which works on the surface science, surface and interfacial phenomena, macromolecular systems, and electronic and structural properties of low-dimensional substrate structures. These are experimental works, mainly, and these are our departments. So you have altogether like 4 departments, and you have also here web pages of this department. So if you are interested in more detail, you can just take a look on these web pages, and you can learn much more than I can tell you at the moment. So let me also mention about the National Synchrotron Radiation Center, Solaris, which is located nearby, like 2 kilometers from here. And this is independent, it's our facility with independent financial sources. This is really very interesting, large experimental place. And if somebody would like to visit the place, please tell me. So I try to still arrange some visit in Solaris. Okay. Now, moving from material science to atomic physics and optics. Again, here we have several laboratories which works on lasers and nanophotonics, physics of plasma, hyperpolarized Nobel gazers for lung diagnosis. This is connected to medical sciences we have. And we have also some fundamental research in quantum information, quantum computation, and in quantum many-body systems. So these are performed by 2 independent departments, the Department of Photonics and Department of Atomic Optics. And those departments work both in experiment as well as in the theoretical studies. Biophysics and medical physics. This is also interesting part of our scientific curricula, and there are several research which is going on at the moment, and these are here, like biology of extracellular microvesicles, in vitro models in radiobiology, soft tissues mineralization and 3D visualization of this, biomolecules at surfaces. So this research are connected with our research on material science and controllable biointerfaces. These are subjects which we are particularly interested in, and this is realized, actually this subjects, we have 3 departments that cover this research: the Department of Medical Physics, Department of Physics of Nanostructures and Nanotechnology, Department of Molecular and Interfacial Biophysics. Those are 3 departments. Now, about applied computer science, let's take a look at the 3 first items here. We have something which we call game physics, and this is part of the curricula which very strongly collaborate with many external companies to development games. So this is very important part of the industry here, and we have really very good collaboration in the subject. We are studying also as a group who study machine learning and data science. This is also very popular topics in the world. And actually those 2 we are trying to connect with some cognitivistic studies, and try to connect this machine learning and data science to the let's say research on brains. So we have quite research. Actually, we have obtained a lot of funds of the order of 20 million Polish zloty to perform research between machine learning and the structure of the human brain. So this is an interesting subject. Of course, we have some more theoretical subjects here, and also in this applied computer science. So like theory of the graph structure and graph transformations and representation, which is important in some way for computer, for applied computer science, processing and modeling, design of knowledge, and something which is called embedded systems. Now this last part, texture recognition, there is also a small group who works on this subject, and which is connected again to our medical physics departments. So altogether we have 3 departments here: Department of Games Technology, Department of Design and Computer Graphics, and Department of Information Technology. Those 3 departments cover all of the subjects. Now, there is a lot of research, let's say, in fundamental physics. This is particle and nuclear physics, and as you see, these are a list of the experimental physics. We have high energy physics experiments connected to Large Hadron Collider at CERN, ultra-relativistic collisions of heavy ions, again, several collaborations, which are large collaborations at CERN, searches for CP violation, physics of neutrinos, dark matter searches. So all those groups are connected to these large collaborations, which are very, of course, well known in the world of particle and nuclear physics. And again, we are also works on development of particle detectors and some electronics, as well as we are working, again, this is something very specific. We work on some new technology, which is a positron emission tomography scanner, which is based on the classic scintillators and not like the usual filter devices. So this is, we are trying to develop this new technology in our department. So again, here are 4 departments of experimental computer physics, hot matter physics, particle physics and applications, and Department of Hadron Physics. All those departments works on this fundamental researches. Now we also have the theory group who works in the fundamental domain, and these are some highlights like radiative corrections to standard model processes. This is important for also for experimental collaborations, Monte Carlo event generators, but also phenomenology of particle physics, quantum chromodynamics, study of the quantum chromodynamic phase diagram, some other, let's say, non-perturbative, let's call it that way, physics, mathematical physics connected to the nuclear system. And again, this is, we have 3 departments who work on this: Department of Applied Computing Methods, Particle Theory Department, and Department of Theory of Nuclear System. There are 3 departments. Now we have also a very strong group in condensed matter and statistical physics theory. Again, this is the most important subjects who is currently under study, and we are working on theory of acoustic processes, theory of modeling liquid crystals. We are working on strongly correlated fermion systems, and also some applications in some new theoretical methods which are based on quantum tensor networks and quantum tensor network algorithms, and some fundamental aspects of quantum physical behavior. These are fundamental studies. Again, and 3 other departments here: Statistical Physics Division, Department of Condensed Matter Theory, Quantum Many-Body Theory department. And finally, we have something which, let me call in general, mathematical physics, which includes general relativity and something which is called complex system. And again, as you see, we are working on classical and quantum field theory, fundamental aspects. Random matrix theory is mathematical theory, which can be applied for many complex systems, and also some fundamental research on string theory, quantum gravity, and general relativity hydrodynamics, supernova models, and that kind of research. And again, 3 departments of field theory department, Department of General Relativity and Astrophysics, and Theory of Complex System department. 3 departments. And these are very strong departments, and very renowned. And let me finally say to work, we have also astronomical observatory. And this observatory is located actually on the opposite side of the Vistula River from here, and very nice surroundings. And in this observatory, we are working also in large collaborations works on evolution of galaxies, investigation of dynamic and physical and chemical processes in comets, investigation of the radio scale, sky at low frequencies with LOFAR, so this is a special system. We are also astrophysics of highest energy gamma rays, and again this is international collaboration which is called HES. We study also coronal mass ejections, CME, and we have a very small department of cosmological models. We are theory. These people who work here are theory. The theoretical department, and as you see, again, 4 departments cover all of these subjects. Maybe I read this. And finally, we are part of the many networks and European programs. We have quite large program for schools and public activity. Let me just mention, for example, that we have some dedicated program for high schools. We have laboratories for students from the high schools. We have special lectures, challenges and contests, and we collaborate with around 70 schools from actually our region here. We give a public lecture series with over 30, I think already about 40, which is called Closer to Science. This is the name of the Jagiellonian in Polish language. And we have also special journal for teachers and students, which is called Photon Neutrino. And we have quite a lot of collaboration with some external industry, but this is maybe discussion for, but maybe not at the moment. Then we can discuss this later. Okay, I think that I stop here. So if you have some questions, you have still like 6-7 minutes, so you can ask me some more.
First of all, we should thank to our speaker. Do you have any questions, suggestions, remarks? It's a good time to.
Very briefly. It's really interesting. Okay.
So, I think that, yes, please.
I've seen on some slides that there is simulations of liquid crystals. So it's quantum chemical calculations or just some Monte-Carlo simulations?
Well, this is a very detailed question. So these are, as I understand, so these are not, so we are asking about the molecular.
Yeah.
So this is detailed molecular show. So to my knowledge, this is not that level. Okay, so these are not molecular calculations.
Please.
You talk about 150 PhD students.
Yeah.
And how many theses are defended every year?
I think that about between 20 and 30, more or less. And our open position for PhD students is around 15 at the moment. So this depends on time, and it also depends on how many external grants we have. So we have 15 positions for PhD students, which is promised every year. But if we have additional sources, and usually this is the case, I think that we open like 10 or 15 more. But this depends on particular researchers.
No question.
So success rate. Okay, so success rate of those students is very high. I don't know this number, but it's like 90% or so.
Well, just see on this slide, well, there are network programs.
Mm-hmm.
This is the 7 framework programs. How often just you apply for Horizon 2020 or participate or collaborate within the consortium?
I think that as I remember, we have like 4 or 5 such programs at the moment. Yeah. So this is this kind of number.
Okay, so thank you again, our speaker.